Good morning, everyone. Welcome to the presentation of my conference paper. My name is Nibras Abbas. The title of my research is Loaded Gate Phase of Normalized Comparison between Older Adults Aged 65 to 80 years and Adults Aged 25 to 45 years. I would like to give a special thank to the audience and to the conference team. Human gait is basically the way people walk. A large amount of biometric information, such as age, gender, and identity, could be recognized from the patterns of a human walking. A unique pattern of individuals' gait through the movement of their upper and lower limbs has stimulated numerous recent computer vision publications. From the moment of one foot heel ground contact until the moment of next heel contact by the same foot is what the research defined the period of a human gait cycle. Due to age-related deterioration of the balance and the neuromuscular systems, falls experienced by older people during gait could result in serious injuries. The risk of falls sustained by older people can be increased because of stability and balance problems, which in turn may impair the foot function during normal gait. The study was designed to examine the variations of dynamic plantar pressure between older adults and adults. The purpose of the present study was to highlight the gait patterns of normal walking for the older adults group by comparing them to the adults subjects group in 5 anatomically defined plantar regions to thoroughly understand the causes of impaired balance control during the whole stance phase of the gait cycle. The study evaluated the plantar pressure parameters based on the average weight for each specific group for the comparison between the two selected cohorts. 40 subjects were recruited in the study to perform gait trials at their self-selected speed using an insole pressure sensor system. The study adopted an insole pressure sensor system sampling at 100 Hz for capturing plantar parameters, namely contact pressure, force, peak pressure, force time integral, and pressure time integral. The collection of the plantar pressure parameters was self-captured for the two participating groups, older adults and adults. Subjects were provided with standard shoes of different sizes. Each subject was asked to wear an appropriate size from these shoes with an inserted insole F-scan sensor. A standard gait was required to be carried out by subjects, represented by the standing position at the commencement, followed by proceeding forward along a 10 meters walkway at their self-selected gait speed, repeating the same gait test for each participant for the following week for measurement purposes and for the reliability of subjects' tests. The plantar parameters beneath the foot were measured and computed using F-scan Research version 6.7 software for a number of plantar regions, namely the whole foot, heel, midfoot, forefoot, and the hallux, to study the variations of foot loading patterns for the whole stance phase of the gait cycle between the two selected cohorts. older adult aged 65 to 80 years, and adult aged 25 to 45 years. This figure shows the 5 regions adopted in the study, which are the whole foot, heel, midfoot, forefoot, and the hallux regions. An insole-based assessment system to measure normalized plantar pressure parameters has been shown in the following figures. These figures depict the comparative plantar pressure distribution values of contact pressure, force, peak pressure, force time integral, and pressure time integral between older adults and adult subjects, taking into account these parameters as a percentage of the average weight for each group that hypothetically might have an influence on the amount of pressure parameters distributed in selected plantar regions. Contact pressure results, taking into account the weight factor when analyzing the differences between the two selected groups, showed higher values for the older adult group and lower for the adult group, particularly under the forefoot and hallux regions. These findings are consistent with other studies investigated previously, who have identified elevated plantar pressure levels under the forefoot area for older adults group when compared to both adults and children's groups. Analyzing their gait during barefoot walking using a pressure mat system designed to place halfway in a 9-meter walkway. The high pressure values distributed on the region of hallux for older adults group in our findings illustrated an association with the foot difficulties encountered with advancing age under this foot plantar region. This can impair the gait stability and accordingly the walking balance, which may increase the risk of falling for this age group. Our research findings demonstrated that the older adults group had higher force values when compared with the adults group at the whole foot, heel, forefoot, and hallux regions, while wearing in-shoe sensor attached to an appropriate shoe size for each subject. However, the older adults group had lower force measures under the midfoot area compared to the adults group. The older adults group displayed higher peak pressure measures than the adults group underneath the whole foot, forefoot, and hallux regions. In contrast, the mean midfoot peak pressure for the older adults group was lower than that of the adults group, reinforced by the results from research undertaken by previous studies. Our findings from this investigation highlighted that the excessive peak pressures in older adults group may be explained by the age-related change of the ankle-foot mechanical properties and also the changes in the characteristics of plantar soft tissue. For the older adults group, excessive peak pressures distributed under the forefoot region, including the hallux area, than those under the heel and midfoot areas during gait can result in foot injuries and lead to the development of ulceration under these regions. This would account for the prevalent conditions in older adults' forefoot site, including the area under the metatarsal bones, which in turn might hinder their normal gait. Older adult group results revealed higher force time integral values under the whole foot, forefoot, and hallux regions. However, the midfoot area showed lower force time integral values in the older adults group when compared to the adults group, as appears in this figure. Our result of comparable pressure time integral measures between older adult and adult groups exhibited a number of remarkable findings, as shown in this figure. Difference in mean pressure time integral values was noticeable, with the older adult group significantly displaying higher measures under the whole foot, forefoot, and hallux regions. These findings were supported by the results of the study conducted previously. The appearance of plantar ulceration can be attributed to an excessive amount of pressure time integral, which is the area under the time curve of peak pressure. Research has shown that excessive integral values distributed underneath the forefoot and hallux areas can result in increased forefoot pain and possibly in developed foot complaints for this age group. To sum up, with the consideration of individuals' weight in conjunction with analyzing plantar pressure parameters to ensure a compatible set of data, the findings revealed higher plantar pressure values for most of regional plantar regions for older adults when compared to the adult subjects. The p-values for normalized plantar pressure parameters to study the influence of involving the subject's weight while analyzing these parameters on the comparison between the two cohorts are pointed out in this table. The study was conducted to investigate the influence of plantar pressure measurement distributed under 5 plantar regions of the whole stance phase of the gait cycle, wearing in-show sensors, on foot impairments and complaints sustained with advancing age through the comparison undertaken between two age groups, older adults and adult subjects. The research included the subject's weight when analyzing research parameters to study the influence on plantar pressure patterns comparison between the two cohorts participating in the study. The results revealed higher plantar parameters under a number of plantar regions for older adults compared with adults, especially underneath the whole foot, forefoot, and hallux regions. The research provided an evaluation of the human gait while adopting in-show sensor systems for older people with the control data, the adults group. The plantar pressure patterns measured during the entire stance phase of the gait cycle were substantial in terms of thoroughly enhancing the plantar pressure distribution visualization of the whole foot plantar, thus assisting the provision of insights into plantar pattern variations due to the aging factor, which can contribute to understanding the causes leading to an impairment in the ability to maintain the balance control necessary for older people during gait.